That probably means I can do stuff.
Yeah.
Okay.
He is now the host.
It's told me I'm the host.
Well, I guess I dethroned myself.
You booted yourself out of there.
Again, this happens, man.
All right. I am going to share my screen. Wow. That's so funky when it does that. So this is that Ray probably wasn't around for this, but Jim had found something on Tom's Hardware about how to use an easy way to use the Arduino Uno or Mega or whatever with a Raspberry Pi. And it's basically Fermata firmware. So this is the Fermata code to make it all work. And that's what it looks like. This one right here is what it looks like to actually make an LED fade. So you can do pulse width modulation, you can do digital on and off, you can do analog readings on your analog pins. So that works pretty well.
Now, this allows you to look at your I/O using your
Yeah.
using the, what do you call it?
It communicates over the serial port, so it's using the USB.
So the Raspberry Pi is basically the computer that is just polling the
And I
Arduino.
just killed my Raspberry Pi. I pulled the power out. Anyway,
So
Raspberry
polling,
Pi,
is it interrupt driven or just?
No, it's actually two separate programs going on.
So it's just polling.
Okay.
Is serial communications? It's saying, "Hey, go pull this register. Go pull this register. Give me an answer. Go pull this register. Give me an answer." So
yeah, pretty much. That's pretty much
And
what it's
does
doing.
it not do anything if there's nothing changed?
It's just sitting there waiting. Now I gotta wait for the Raspberry Pi to come back up because I pulled the power out.
But anyhow, it looks pretty cool. And it maps out an I/O table on the Raspberry, and you know where all the I/O is.
Yeah. Cool. You have to. I'll show it again. But when you're doing PWM stuff, you actually have to tell it how to do it. It's a little bit more complicated, but the general program, the Python program, just to blink an LED it's pretty much like blinking an LED on the Arduino.
Now, the Blink program is running on the Arduino or on the Python?
No, Fermata's running on the Arduino.
Okay. So it's emulating an Arduino basically, or the code's similar to that of an Arduino.
It's similar.
And it's transparent to you that it's talking to Arduino I/O. The software is running on.
Other than the fact that a bunch of LEDs light up, yeah, it's pretty transparent. Okay. Let me log back into my, get it all turned back on. I won't move the Raspberry Pi around anymore. Oh, Oh, where'd it go? There it is. So this line right here, digital pin 11 is a pulse width modulation pin, and the P tells it to use it like it's pulse width modulated. And this line right here is your COM port number. Like if you were using Windows, that would be a COM number, like COM.
Yeah, that's a device, TTY.
Yeah, it's a serial device is basically what that is.
Yeah.
And if we just want to blink a light, you pretty much do the same thing. Digital write 1, that's the pin number, and digital write 0, so it's a high and a low. So if we were blinking an LED, and then that line is like a delay in milliseconds. Actually, I think that's actually in seconds.
Seconds.
Yeah, I think that's actually in seconds. So if we were to run this, and if I were to stop sharing, the red light is blinking every now and then. The yellow light will blink, and the green one, you can't really see it. It's fading. It's going fading up and fading down.
It's easier to see it fade down.
Yeah. And the actual blink sketch is way easier. It's way easier to deal with. So when I reset when I sent a new sketch to it, it reset everything, and it reset the pins. So now it's just blinking the red LED. Blink, blink, blink. And that's the blink thing. Is you've got the LED set to pin 13, digital write, high, wait half a second, digital write low, wait half a second, and do the whole thing over again. So easy, I guess. I'm thinking, I wasn't real sure how to control the Mega that I've got in my Hero robot. This might actually work well for that, because I don't even really have to deal with pulse width modulation or anything. All I'm doing is turning pins on and off. So this might work
cool.
really well for that.
Yeah,
that was my fun thing. That was my fun project.
I have oh yeah.
That one, that's an old kit from years ago that I finally put together. It talks, it listens. So if you say left, it'll turn left. If you say right, it'll turn right. And it's all self-contained. But the battery lasts all of about 10 minutes. That was another one of my things I did. Actually put that together last night.
Have to see Steve about a bigger battery.
It's like one of those little drone batteries that, the ones that last about 10 minutes or so. I'm surprised it lasts as long as it lasts.
I got a project that'll make you a fortune.
Okay.
You ready for it? Here's a device. You have a device the size of a pen, ballpoint pen, and it has a battery in it. And if you get this ballpoint pen, it has a switch on it, you turn it on. If you get this ballpoint pen within 6 foot of a similar ballpoint pen, it will start beeping. You could sell millions of these.
Okay.
Do you know the application that we're talking about?
No.
Tell him, Ray. You don't know what's going on, the social spacing?
I thought you were be like some kind of a gaydar. I don't know what you're doing.
No, this is happening where Gail's working. They want to. She's saying, "Hey, you could make something that tells me when you're within 6 foot of somebody else." They're watching them and judging them and saying you're too close to other people. Sometimes you could sell millions of these, and you could get those little cheap AM transmitter receiver things, and approximate 6 foot relatively easily. I'll make you a millionaire, Ray.
Make me a millionaire. Okay.
Yeah. Sell them, make them for about $1.50 a piece, and sell them for $20 a piece. You'll be a millionaire. Again, a millionaire your second time. I know.
It'd be your third or fourth time.
Yeah, right.
What you glean off of Gail. I don't know. This whole 6 foot thing, man. Maybe you could do that great in California, but then they'll sue you in 5 years and say that your item causes cancer.
Yeah, well, that's why you have a good disclaimer. You're familiar with disclaimers and stuff. You'd be big.
Nothing's gonna be enough.
Yeah.
Doesn't matter what you do. That somebody's gonna try to sue you for something, and then there'll be this lady on TV late in the evening that says, "If you've been a victim of this, we want to represent you, and we'll sue them for you."
You've been a victim of the laser rabbit person detection unit.
Distance detector.
Yeah.
The
Social-
proximity detector.
Yeah.
I did make a cool device last week. I didn't even know if I told you guys about that. All I do is it's an easy tool for detecting, is my sensor good or not? And some people don't really know how to use a multimeter, don't want to change it back and forth, don't know which items to connect. So this is pretty easy. You just plus voltage, ground, and sensor input, and it tells you this is the main voltage coming in, and if it's good, green light and red light, and just to make it easy. We've got various other test tools around the building, just trying to say go, no go type of sensor tests, but always trying to make stuff easier.
Is this like a microphone sensor test or?
No, we have proximity sensors. 'Cause this is where it came off the proximity thing. And they're testing if your part is like passing in front of it's called a flag, or a component in the laser machine. So it's a limit switch. Did your axis move too far? Did it get to the home position, stuff like that. And some of these 3-wire sensors are confusing. Like, is it working? Is it good? Does it work down to 5 volts? Does it work down to 10 volts? So these things will tell you. We've got other stuff. Is like, if you plug the safety interlock connector into the chiller, does the chiller work? Does the cable work? And instead of having people and teaching them where to plug in the multimeter, you just say, plug the cable into this box, push the button, the light turns green. If the light doesn't turn green, something's broken.
Cool.
So in this case, I bought some little displays. It's here. I ought to go grab it. Be back in a minute.
I can't find the program now. I'm so confused. This thing was cool. It was listening. This weird little thing. It was listening to me and everything. I can't find the program I used.
Hello, I can do ultrasonic avoidance now. Do I need a calibration?
Yes.
Okay, let's do the calibration. So, this is how this works. I will do an action, and you tell me yes or no. Let's do this. Did I just turn right?
Yes.
Thank you. So, did I just turn left?
Yes.
Thank you. So my left motor's forward direction is 1. My right motor's forward direction is 0. You should change the forward direction setting in the code at motor definitions. Calibration is done. You can check the result on the terminal output. Now, shall we get started?
Yes.
Okay.
Sorry, Ray. Go ahead.
That is pretty cool. Way overcomplicated, but
Way
hey,
overcomplicated. but cool nonetheless.
but cool nonetheless. Yeah.
That requires a Raspberry Pi 3B, not the B plus, not a 2, not the original Raspberry Pi. The 3B is the only one that will work with that thing.
Good grief.
Yeah. One of the boards that is on this is attached with pogo pins, and they have to match exactly where. And the 3B plus doesn't have the same lineup. None of the other ones have the same lineup. But it's cool. It's fun. I can't find the program where I could actually tell it to turn left and right. I don't know what I did with that.
So this is one of my toys that I made recently. So we've got a power coming in here, switch, 2 displays. One's the power supply display. The other one is the voltage is being seen at the sensor. And we've got buttons. We're trying to simplify this a lot. So we've got a button that says pull up for the sensor, pull down for the sensor. And then we adjust the voltage that's being delivered to the sensor, and then where to actually plug into the sensor. So I actually make this wall powered instead of battery powered. And over here, turn the power on. And here we go. So we've got the main power that it's seeing right now is 24 volts. And because of the wire that's going from the delivered power adjustable to the sensor, it's tuning up and down. So right now I'm just dialing it up to 24. And this is a nice little tool because I can just tell my employee, go ahead and plug in the sensor, power down here, ground, and then the signal. And then what you do is you dial it until it's like, okay, well, it doesn't work below 6 volts, or it doesn't work below 12 volts. And it's supposed to work all the way down to 5. And it's like, okay, well, the sensor, the way that we use it is at 24 volts. So does it start to flake out above 22 or 24 or what? So I thought, okay, well, I was at home and I thought, okay, I'm going to go ahead and take my little proximity sensor and I'm going to plug it in here just to make sure, hey, is this thing working right? And I screwed around with it for an hour before I realized this sensor doesn't work, okay? Which is what the tool is for, to tell me that the sensor's broken. And I was like, wondering, why is my tool not working right? And it was working right. It was telling me the sensor's broken. So it was funny. But the whole point of it, you know, was to be able to tell, hey, this sensor's not working. So when you turn to a certain point, you say, hey, it's working at, let's say, 12.5 volts. The sensor will cause the 12.5 to drop down to 0. And then, you know, you turn it up to a little bit more, whatever, turns it to 5, they'll drop it down to 0. Or I can plug in a switch and, just a limit switch. And I want to tell it to go ahead and I'm going to do a pull up, and, you know, using the pull up connector or pull up switch there. Or if I'm going to be doing a pull down, and like my switch will be connected to a resistor or the plus voltage. So that way at my signal, I'm going to see what's happening there. So this is my first prototype just to see, hey, how's this stuff working? But it actually is doing pretty good. The only bad thing about it is there's no instructions to tell somebody else how to use this tool. So I'm going to put the instructions just here on the side, and I'll use another laser to engrave what the instructions are and what the terminals are used for. So that's my new toy that I play with.
That's
Cool.
kind of cool.
Yeah, cool.
The biggest trouble with building that was trying to find a 24-volt power supply that had 2 amps and would fit inside the box and you know, still have space for the meters and the switch, fuse, connector, all this other stuff. There's a 2-watt potentiometer down the inside, so there's not a whole lot of space, you know, plus the 24-volt 2-amp power supply. I got lucky to find one here in the building. So then I found out, hey, I don't have one, I got like 20 of them. So it's cool.
Yeah.
It's a type of power supply we use for water pumps. And once you strip the plastic casing off of that water pump power supply, it fits in here nicely. But these little displays, I bought some that are in red and blue and green, and it helps you to differentiate what you're working on in the project. I'm always building these little, I keep forgetting that I'm putting the box down out of view, but I'm always building little projects to, you know, a test box, a control box or something. So I went online, I was looking to buy some, and they're anywhere from $6 to $10 each on eBay. You can buy them from Jameco and other places, but they're still kind of expensive. And I found 58 of them for $100. So I went ahead and I bought them. So I've got like, you know, 57 more.
Cool.
But we'll use them for different stuff, I hope.
Micro Center was, they were clearancing out a bunch of their project boxes. I didn't go down and get any of them. I didn't really know that I needed them for anything.
I've got a bunch of really small ones, a little bit bigger, and then these, and like just a very few that are bigger size. So you can see here, I've been trying to do analog meters, potentiometers, and stuff like that. It just makes it a lot easier to tell somebody, hey, this is the device that we use for testing this situation. Plug this in, look at the number, and you're done.
Yeah.
And it's so much easier, better, safer than really trying to get somebody to understand all the different ways to use a multimeter. That just doesn't happen. I'm still working on my my easy automation thing, so I'll work on that later.
Cool. I'm playing robots. Mostly I'm playing with the Raspberry Pis that I've had sitting around and not doing anything. That's what I've been doing the past month, is playing Raspberry Pi stuff. That's a Raspberry Pi Zero with OpenCV on it. So there's a little camera.
That's cool.
Yeah.
You guys feel like the Zoom meeting method is killing our attendance, or what? COVID is killing our attendance, but hey.
Not being able to go anywhere.
Yeah.
Yeah. So I kind of like the Zoom meeting, and may start using it more even at the meetings, like if somebody wanted to virtually meeting. It seems to work well.
Seems pretty stable. You know, I haven't been here much, but it seems pretty stable.
Yeah.
I think we had several people last time.
I'm impressed with the code. I mean, this is just very intuitive. Just works.
The interface?
Yeah. Yeah. I mean, it's simple enough. It just works. And then there's some features in there that if you start poking around with it, you'll find can do other stuff. So I think it's a good,
either one.
Good thing. But
okay.
Vicente was actually the one that suggested doing something. And
Hey, whatever. Don't give me anything. I'll just eat off your plate.
He forgets to show up. All right. So it looks like this meeting will end in about 10 minutes.
Yep.
Well, I don't really have anything else to contribute. I'm always interested in what you guys have been working on.
Yeah. Well, that's. I thought people might get a kick out of that Fermata thing. That I think I'm going to start using that because it seems to work. Seems to do what it's supposed to do. A little bit of a learning curve to it. But.
You can also use this on your phone.
Yep.
So when you're out prowling around, Ray, you can check in. And Leroy's recording it too, so you can look at the archives.
Yeah. So.
Okay.
Assuming you have a strong stomach and all that.
Vicente's here. Vicente's late.
Vicente. Oh, there he is.
He's here, but he's late.
The late Vicente.
The late Vicente.
Hi, hello. I almost missed the meeting.
Almost. We've got about 8 minutes left. Our free time is just about up.
Hi, everybody.
You say hi to Vincente.
In-
Vicente.
Anything new?
Yeah, I just have my new programmer. Can you see me?
Yeah.
Yes, dear.
From China. This is the
Oh, that's cool.
programmer, the flash programmer for the 3 cents microcontroller.
Okay.
This one works with the flash devices, so I can reprogram a lot of times the same thing instead of burn out each time I try something. It's working.
What chip series is that for?
This is Padauk. It's Taiwan company.
No, what type chip is it for?
What type?
Yeah, is it for a PIC chip or a?
It's like a pig, but it's not a copy. It's a real development. It's different, but it's from Taiwan. They have their own compiler, their own IDE to work. It's pretty nice. Pretty.
What's the name of the?
Let me send a link to.
Oh yes.
To see how I met this chip. Just a second.
You're going to have to go back and watch the video. I played with this PiSmart car, and I played with Fermata.
Okay, it's pretty easy.
Yeah.
Just search in YouTube for 3 cents microcontroller. Okay, there are the first 3 videos explain everything. Okay.
Share your screen.
3 cents microcontroller.
You can share your screen.
Let me share the screen. Just a second.
This thing is really, really neat software.
Can you see the screen?
Yep.
Okay, this guy from Australia explained everything. He explained where to buy the microcontrollers, where to buy the programmers, and he shows how to make a simple blinking sketch. And okay, it's perfect. I just went to the place he suggested and bought everything. For $3, you buy 100 microcontrollers. This is the
3 cent microcontroller?
Yep.
It's a one-time programmable deal too.
He's playing everything. You don't have audio, right?
You got your headset in, so we can't hear the audio.
No, but oh, it's interesting. Just see the first 3 videos, and there is everything about the microcontrollers.
Okay.
This is the microcontroller I am using in my board that I showed last week. the
Yep.
Can you see me? Let me stop sharing this. Okay, this is the board I made about the STM32, the ARM microcontroller. I am using the 3Sense microcontroller to control the reset of the micro. Because you need to make a sequence of changing the boot pin, boot 0. You need to change it to 1 and make a reset, and then put back the pin back to 0 for running. Usually the blue pills boards use jumpers to do that. You use jumpers to change to serial boot loading. I'm just using the 3Sense microcontroller to do that. I just checking the reset button, and if you keep the button pushed for 1 second, it changes to programming mode. Now any open of the serial port will initiate the boot loading of the software. After that, you can go back to the normal running, pressing for 1 second, and then you have your microcontroller running without problem. Usually when you do this with an Arduino, each time you open a serial port, the serial port reset the Arduino. You know, and sometimes it's a problem if you are running something and you want to know how it's going and to see the serial terminal new values. Usually you reset the Arduino doing that.
Right.
In this way, in this mode, any new open of the serial port doesn't produce a reset. So you can see what's going on in your program that was running for a day or for several hours, and you see fresh data about what's going on. It's pretty nice. This is the tiny thing. I just put all the pins of the microcontroller in the board. You can access all the. This is an ARM microcontroller, and can work with Arduino or any IDE from ST Microelectronics.
30-second warning.
Okay.
We're almost done.
That's it. Well, sorry to be late.
You're a little early next week.
Next week.
Yeah, come a little early. We got to get you a USB plug-in microphone, though.
Yeah, I need that. I have plenty of them in a box in somewhere in the basement, an unfinished basement, but I always forget to pick it. Next time I will do it. Okay.
All right. Thanks, guys.
All right.
Nice to
We'll
see
see
you
you
all.
next time.
Bye.
Bye.